Welcome all. Today we can discuss the section of solids and development of surfaces, problems including both section of solids and development of surfaces. Here is the question. A pentagonal prism 30 mm base side and 50 mm axis is standing on HP on its base whose one side is perpendicular to VP. It is cut by a section plane 45 degree inclined to HP through midpoint of the axis. Draw front view, sectional top view and sectional side view. Also draw true shape of the section and development of the surface of remaining solid. And this is the first step. Here we must draw the top view of the pentagonal prism whose base side, the length of one base side is equal to 30 mm and axis height is equal to 50 mm, and one side is perpendicular to VP, that is the given condition. Then one side must be perpendicular to VP. Then for naming purpose we can choose the notation like this. Here this point is A in bracket 1, here B in bracket 2, C in bracket 3, D in bracket 4, then E in bracket 5. We can use this notation, that is more convenient. The top face of the prism is represented by letters and bottom face represented by numbers. That is the more suitable method. Then we have to find out the center of the or axis point of the pentagon. We can draw two construction lines which is inclined 54 degree with the base side. Then the meeting point will become the axis point. Then we can draw the front view. Here this points, these points, the first point, this point is A dash and this point is B dash in bracket E dash, then this point is O dash and this point C dash visible but D dash invisible. Then similarly the bottom points, this point is 3 dash in bracket 4 dash, this point is P dash and this point is 2 dash in bracket 5 dash, then this point will become 1 dash. This is the pictorial representation of the front view. Then we can represent the midpoint of the axis. Then we can represent the section plane. Section plane is passing through the midpoint of the axis and also inclined 45 degree with HP. Then we can draw a horizontal line, construction line, which is passing through the midpoint of the axis, and then we can draw the section plane which is inclined 45 degree with that construction line. Then we can use a chain line with end thick lines to represent the section plane. Chain line with end thick lines. Then we can draw the visual rays like this, and we can represent this as VT, vertical trace of the section plane. Then almost all conditions are satisfied. Then we can draw the side view of the solid. Then for that purpose we can draw a straight line which is inclined 45 degree with XY line. Then we can project all the points from the top view to that line. Then we can draw the vertical lines from that intersecting points. Then this will become the side view. Then we can locate all the points which is the intersecting points of this section plane and the front view. Section plane and the front view. We can see that while cutting this front view or front view of the solid, we can remove this portion and we can transfer a dash from this point to this point. Similarly, we can transfer b dash e dash from this point to this point because these portions are removed. Then this part will become the top face of the sectioned solid. Sectioned solid. Here, sectional top view become like this. We must draw that section plane or section or hatching lines. Hatching lines. Then while locating the points in the side view, we can see that the point E, top view of E is this point, then the locus of E is this line, this particular line, this particular line. Then we can project or we can draw a horizontal line which is passing through E dash. Then that meeting point will become E. Similarly, we can locate the point A, the meeting point of the horizontal line which is passing through A dash and this particular line. That point will become A. Then we can locate all the points A double dash, B double dash, C double dash, D double dash, and E double dash. And this is the sectioned portion. Then we can draw a pentagon. We can draw a pentagon in the side view. Then we can draw all the vertical edges of the remaining solid by a thick line. Then invisible edges. Here in this is the side view. Then in that side view we can see that D4 vertical edge D4 is invisible. C3 also invisible. Then D4 and C3 must be in thick line. D4 and C3 must be in broken line. This edge and this edge must be in broken line. Here this point is point 2, 2 double dash, and this point is 1 double dash, and this point is 3 double dash. Similarly, this point is 4 double dash, and finally this point is 5 double dash. We can look at all the points in the bottom face also. And this is the side view which showing the sectioned portion. That is sectional side view. Then we can hatch that sectioned portion, and that section hatching lines must be inclined 45 degree with the horizontal direction. That section plane, hatching lines must be inclined 45 degree with the XY line. Similarly, we can hatch this portion also. This is sectional top view, and this is sectional front view, and this is sectional side view. And this is the representation of sectional side view and sectional top view. Then we can draw the true shape of the section by drawing a visual rays which is perpendicular to section plane. By drawing the visual rays which is perpendicular to section plane, and we can draw an XY line which is parallel to section plane, and we can draw we can locate all the points A, B, C, D, E, and the distance of that point A, small letter A, from XY line must be equal to distance of capital A from X1, Y1. Similarly, we can locate here this the distance of A1 from X1, Y1 must be equal to small letter A, distance of small letter A from XY. Similarly, we can locate all the points A, B, C, D, E, etc. Then while connecting all these points, we will get the true shape of the section. True shape of the section. True shape of the section. This is the first part of the question. First part of the question. And coming into the second portion, second part, we must draw the development of surface of the remaining solid. We must draw the development of this a lower portion of the solid, because the upper portion is already removed. For that purpose, we have to draw a straight line which representing a straight line which representing the stretch out length of the solid, stretch out length of the surface. This is the stretch out length. Stretch out length. Here stretch out length is equal to 5 times 30 mm. That's equal to 150 mm. That's equal to 150 mm. 150 mm is the stretch out length. Then we can locate the first point, point 1 here. Then the distance from 1 to 2 is equal to 30 mm. 2 to 3 is equal to again 30 mm. 3 to 4 again 30 mm. 4 to 5 again 30 mm. Then 5 to 1 again 30 mm. This is the stretch out length. We must draw the stretch out length first. Then we can draw the vertical construction lines passing through 1, 2, 3, 4, 5 and 1 again. Then we can transfer the distance of A dash from XY line. From XY line, we can draw the horizontal line which is passing through A. Then the intersecting point of that horizontal line and the vertical line which is passing through 1 will become capital A. Will become capital A. Similarly, we can locate capital B, capital C, capital D, capital E, and finally capital A. Then we can connect all the points. Then that will become the development of the lateral surface. Development of the entire lateral surface. Then we can draw vertical lines which showing the folding lines or fold lines, which shows the fold lines. That fold lines must be in medium thick lines. Here 2B is a fold line, 3C is a fold line, 4D is another fold line, and 5E also another fold line. We can draw that fold line also. Then this will become the development of the lateral surface of the remaining solid. Development of the lateral surface of the remaining solid. Thank you. Thank you all.